All right, so we are going to start the second lesson of our statistics unit, looking at the name of the whole unit. We're going to look at the idea of normal distribution. Before we start that, we're going to go back a little bit to some things that we've looked at in the past. That's the idea of talking about the central tendencies, or the central tendency of a graph, right, or of some data. What that is that's three ways in which we measure the center, right? Three different sort of centers of some data. The middle. We can talk about the mean, we can talk about the median, and talk about the mode. And these are three things we've looked at before. Mean. This one is often what we call the average, is where we find the sum, right? We add up all of the different values in a set and then divide by how many values we have, which is giving us the average amount, right? If everything was to cost exactly the same, what would that cost be if we know the total that everything adds up to? The median talks about the actual physical middle. So if I sort my numbers from least to greatest, I'm asking myself, what is the value that's in the exact middle, right? If I get rid of everything, an equal amount of stuff on the left side and on the right side, where am I left with in the middle? And this doesn't care about how much bigger the bigger numbers are or how much smaller the smaller numbers are, right? Just where in terms of location. And then mode, this is our value that shows up the most number of times. This is the most frequent value we have. Right? Out of all the numbers, which one shows up the most common? So let's look at an example. You're buying shoes. Same example we looked at in lesson 1. You find 10 pairs you like and you have their prices. You write them down. So for mean, we're looking at the idea that I'm going to add up. If I was to buy all 10 pairs of shoes, it would cost me $45 plus $36 plus $38, right? I'm going to add up all of these pairs of shoes. If I was to total all 10 of those pairs, if I add them up, I'm going to save us some writing. That's going to be $531. Now I'm going to split that 10 equal ways. Let's assume we're imagining that every single shoe costs the same amount. The price of each pair, right, would be $53.10, right? 531 divided by 10 gives us 53.1. So that's the mean, right? The average price out of all those shoes is $53.10. The median, I want to know what price is right in the middle. So to do that, I want to write the values in order. I'm just going to go through my list and one by one, crossing them off so that I don't lose my place, write my values in order. So 42 is the next smallest. Then I have a couple of 45s, then a 51, a 62, a 68, a 70, and a 74. And I'm just going to count really quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I didn't miss any of my data. Great. So to find the middle, I'm going to start by cutting off on equal sides one number at a time, one pair at a time. So highest and lowest. And then next highest, next lowest. And I'm going to keep going until ideally I end up with one number in the middle. But here I'm left with two numbers in the middle. I want to find out essentially my median is what's right in the middle of these two. Right? What would be right between 45 and 51? Well, that's just another mean calculation. I'm going to do 45 plus 51 and cut it in half, right? That's going to tell me the average of those two numbers, what falls right in the middle. And it ends up being 48. So my mean price was 53.10, right? $53.10. My median price is $48, right? That just means that there's an equal number of cheaper shoes as there is more expensive shoes, but we don't know by how much. Mode is asking me to find what number shows up the most frequently. And well, for us, the only number that shows up more than once is 45. So the most common shoe price, based off of exact rounded dollar amounts, is $45. So notice all of these are different ways to talk about the middle, right? Most common for mode, exact middle for mean or median, average price for mean. But we've looked at all this before. Let's see how we can get a spreadsheet to do the work for us. So I'm going to make sure on D2L, right, I'm looking at my statistics units. I want to go to S1.2 because we're in lesson 2. And you want to open up this 1.2 notes practice file right here at the top, right? That's going to give you all the data that you need so you don't have to worry about copying anything yourself. So I'm just going to have mine open here in a tab. I want to make sure that I'm making a copy of this. Go to File up at the top and then make a copy so that you have your own editable version. Name it something similar, right? I would recommend putting it in a folder so you can stay organized. And it should open up that new copy that now you can make changes to in a new tab for you. So what we're going to do first here is I want to calculate the mean, median, and mode. In a few empty cells, I'm just going to type mean, median, and mode so that I can use those as labels so that I know when the calculator comes up with some numbers, I know which is which. I'm now going to access a spreadsheet formula. So all of these spreadsheet tools, Google Sheets, Excel, Windows, Apple Pages, all have formulas. So what that is you're going to start off by putting an equal sign. That just tells the spreadsheet that you want it to do some calculations for you. It has a ton of them built in, from things as simple as if I type in sum, you can see I can find the sum of some numbers, right? So instead of adding them up myself, I could get the computer to add them up for me. It goes all the way up to crazy trigonometry, right? Things like cosine, things like that. It doesn't, and 100 million things in between. So we want, for mean, this one's a little bit weird. I want to use this average formula. I can type it in or I can click it to select it. And it kind of walks you through it, right? It tells you in summary, return the numerical average in a data set, ignoring text. So if you had words in there, it wouldn't worry about it. Value is the first value you want to start at. Value 2 is the second value, right? Just like we did for the histogram, I can click and drag to select all these numbers, right? The orange stuff is what I'm finding the average of. I could also type this in if I wanted. This is basically saying find the average of all of the numbers from A2, right? Column A, row 2, all the way down to column A, row 11. And if I hit enter, it tells me, right, that mean value, 53.1. We already knew that, right? That was awesome. If we want, we can click this dollar sign to say format as a currency because we know this whole thing was in dollars. Median and mode are actually a little bit more straightforward. I'm going to hit equals. Median, it only tells us, right, there's only one. Great. I'm going to choose the same data sets so I can go A2 to A11 because I know that's where my data is. Hit enter, tells us the same thing. The median was 48. Change that into a dollar value. Mode, same idea, equals, mode, select, and the mode is 45. Right, so easy, awesome, does the work for us. The only tricky part is just remembering that mean, the formula isn't equals mean, it's equals average. Right, and it'll tell you, it'll give you an error. If you tried to go equals mean, right, nothing's showing up. You try to select your values, it's telling you this, unknown function mean, right? It doesn't know what that means. So average is the one we want to go with. So let's move on to why we're doing this, why we're looking at these measures of central tendency we've already learned. So when we compare all three of these things, when we look at how the mean and the median and the mode might be related, that's what we end up calling normal distribution, right? We can decide if some piece of data is normally distributed, right? If it's distributed, if it's spread out in a normal way or not so normal. So when we have our data, when we look at those histograms that we made in the first unit, it can be spread out in a lot of different ways, right? We can see that it's kind of bunched up more towards the left. There's a lot more lower values than there is higher values. Bunched up to the right, there's more higher values than lower values. Or it can be all jumbled up, right? It can be random. We can have different values everywhere, right? That's some ways that we can have data be distributed. The way we're mainly focusing on in this unit is when we end up with something that is kind of centered around the middle. We get this shape that we see here in the image, right? Where it starts low. As it grows, we're getting closer to the middle, and then it starts to fall again. This is data that is normally distributed, right? This is called normal distribution. Sometimes we call it a bell curve, right? Because it looks like a little bell. Right? It goes up in the middle, down at the bottom. There you go. There's your little bell. So normal distribution has this symmetrical shape, right? It's not more larger on the left side or larger on the right side, because the following things are true. First thing is that those three measures of central tendency are all the same, right? The mean, the average price is right in the middle. The median, right, the middle value is right in the middle. And the mode, the most common value, the highest bar, right, because this is telling us, we know that this is a frequency graph, the most common value shows up right in the middle, right? So it's the median, and there's equal numbers on either side, so it's the mean. That means that we end up with symmetry, right, around the middle, because if the mean is right there, then we know that all the smaller numbers and all the bigger numbers kind of even each other out. 50% of the values are less than the mean, and 50% of the values are greater than the mean. So a couple more visual representations we have here. Right, on the left side, normally distributed, we have that the mean, right, is right in the middle. So it is the median, and that's the highest point, right, the most frequent part on our graph. So it also is the mode. And we want to see that equal dispersion on both sides, right? Really focusing on symmetry here. All right, that's a big point. If the data isn't normally distributed, we can look at it in a couple of different ways. This first graph shows something that's left skewed. So it's almost like it would have been a nice centered graph, but then it was pulled out more to the left. And this happens because our mode is bigger than our mean, and probably also our median, right? The most frequent value we have isn't right in the middle. This is telling us that some larger value shows up more often than the rest. We can also have data that's right skewed. So it would be nice and normal, but it's like it's been pulled out to the right. And this is what happens when the mode is less than the mean and probably also the median. Right? Our most frequent value doesn't fall anywhere in the middle. Some lower number shows up more frequently, right? But we have lots of larger numbers to then offset that. So these two on the right are not normally distributed, right? They're skewed graphs. So let's look at some scores. Let's look at the mean, median, and mode and see what we can do with that. So back to our practice sheet. We have example 2 as another tab down here. So we're going to select that one. here we have 24 data values, right, from A2 down to A25. And these are, according to the question, 24 scores recording the average time in hours each person spends driving per week, so their commute to work. We want to determine the mean, median, and mode. We also want to decide if this data is normally distributed. So first thing, we have our data here. Let's find the mean, median, and mode. So I'm going to, right, using my formulas, I have set up a little table for you already. Equals, remember that mean, we want to do average. And it's from A2 to A25, right? Or you could click and drag. So this tells us that the mean is 2.5, right? The average amount of time that people spend driving is 2.5. We can see that we have some higher values like 3.3. We can also see we have some lower values like 1.5. And again, one thing we can do if we want is we can go data, sort range by A to Z. And I shouldn't have selected the title, but it'll put those numbers in order for us. So we can see the least amount someone drives is 1.5. The most someone drives is 3.3. Let's find the median now, equals median. Again, of those same values, I can click and drag. And it turns out our median, right, the number right in the middle of all of those. So again, I'm going to sort just so we can see that. Data. I can see that out of the 24 scores, right, hovering right around the middle, 14, 15, 16 area is 2.5. And then the mode, typing that in, is 2.5, because I can see here 2.5 shows up 5 times. It's the most frequent score. So based off of these numbers we can see, right, we think this is probably normally distributed because the mean, median, and mode are all the same. Let's make a histogram to see what this data looks like. So using what we did in our last lesson, I'm going to select my data, insert, chart, and it recommends a histogram based on the numbers we have. All right, again, we want to customize this. While it can start us off awesome, it's a little bit messy from there. So, working on histogram, my bucket size. Right, I think that a reasonable bucket size this time, because we're dealing with pretty small numbers. Right? Even this bucket size of 0.5 only gives me about 4 bars. So let's go down to 0.25. Right? For every 15 more or less minutes that someone's driving, we can see an adjusted value. I'm also seeing a lot more empty space on the left side of my graph than on the right side. So for my horizontal axis, I want to kind of change that by going up to a maximum value of 4, just so that we can see some symmetry. Right? There's a couple of blank bars on the left. Let's add a couple on the right. And so we can see a pretty good curve here, right? It peaks in the middle. There's about equal distribution on the left side and on the right side. And I can adjust my title and my labels. Time spent driving. Right, we can label our axes. Horizontal is time in hours. Vertical is, we can call it frequency, or we can say number of people, number of employees, whatever it happens to be. So looking at this chart, right, I'm seeing now what the data specifically is telling us. We see this peak in the middle. The mean, the median, and mode all line up in this highest bar that's in the middle of our graph. And then we look, right, it kind of flows out to the left. There's fewer and fewer as we look left, fewer and fewer as we look right. So this is normally distributed, right? So what we can see, there's a couple questions there at the end. What can we see from this graph? Well, we can see, right, mean and median and mode all line up together. Right, that's this bar in the middle, right? It's the highest because the mode, right, most frequent. We can assume that it's the mean and the median based on our calculations, right, and the fact that it's somewhere around the center of the graph. And we can see that it's normally distributed because, again, it makes that bell-shaped curve. If I was to draw a line that hits all of these points, right, the edges of each bar, we see that symmetry, right? We see that peak in the middle curve down equally on both sides. Right? What can change how we see this? Is there anything that we can change? Well, we looked right off the bat when we had it started, when Google made us the graph automatically, when our bucket size wasn't quite as specific, right? We saw fewer bars. It didn't quite make, it made a general similar shape, right? But our bucket size can change how we see this. Things that also affect how we view the data, right, or what the data ends up looking like, is size of sample, right? Sample size. If I was to poll 1,000 people on their driving time, we'd probably even see a more specific curve happening here, right? We'd see a lot more, we'd have more values to work with. So we could see a bigger, more precise change between each step. And so that finishes off normal distribution for us. There is one try. Take what you did in your first assignment and see if you can decide if that's normally distributed. Right? It should be. The answer should be yes. So see if you can get that going. You can also now complete assignment number 2. So remember, going to D2L, you now have access to that assignment number 2. Same idea. You're going to look at some data, decide if it's normally distributed. And you're going to submit this one on D2L. Right? So looking at another set of data, you have access to the pre-filled in data. You're going to decide if 3 different sets of data, if any of them are normally distributed or not. And again, you have your rubric there at the bottom to plan for how thorough you're going to be, what you're going to include. So that finishes off normal distribution for us. I will see you in our 3rd lesson where we talk about standard deviation.